Hey guys, this video is intended to go alongside your PowerPoint on ions that I've posted to the Google Classroom. Today we're going to talk about ions, and ions are formed when an element either loses or gains electrons. Okay, so when an element loses or gains electrons, an ion is formed. And why would an element want to lose or gain electrons? Remember, we talked about the noble gases on the periodic table, which are your group 18 elements, and they are unique because their valence shell, their last shell, is completely full. That makes it a stable element, right? So a full valence shell, which is the last shell, makes it stable. So every element on the periodic table wants to become stable. And unless you're in the group 18 column, unless you're considered a noble gas, you do not have a full valence shell. But there is a way to obtain a full valence shell, and that's either by losing or gaining the electrons that you have in your last shell. So this is how an ion is created, because when an element loses or gains electrons, it has a charge. Now, the electrons and the protons aren't in an equal number, so now the element itself has a charge. So let's look at lithium to show how this works. Let me just erase this page here. So let's look at lithium. So lithium has an atomic number of 3, and it has a mass of 7. So if I were to draw the Bohr-Rutherford diagram, okay, I'm going to draw it over here. My nucleus would have 3 protons. My neutrons would be 4. And then in my first shell, I would have 2 electrons. And in my last shell, I would have 1 electron for that grand total. Remember, it has 3 protons, 3 electrons, and 4 neutrons. And we learned how to calculate these numbers in class before the March break. So that is lithium as it is on the periodic table. Now, is lithium stable? You should be answering no, because its valence shell is not complete. Because how many spots are missing? Well, let's grab a different color pen and let's show it. Remember, the order of electron arrangement is 2, 8, 8. So the first shell is full. That's good. The second shell here has the capability of having 8 electrons on it. Right now there's only 1 electron on it, which means there's an empty space here, there's 2 here, there's another 2 here, and there's another 2 here. So there are 7 spots available on lithium's valence shell. So either lithium is going to lose the 1 electron that it has, so that that shell is completely gone, and now you have a full valence shell with 2 electrons, that first shell, or it's going to gain 7 electrons to become full. Which one do you think is going to happen? Well, I hope you answered lose 1 electron, because that is the correct answer. Lithium will lose 1 electron because it's a lot easier to lose 1 electron than it is to gain 7. So you're always going to choose the lower numbered option, okay? It takes a lot less energy just to lose 1 electron than it does to gain 7 electrons. So what would it look like if lithium actually lost that 1 electron? So let me show you that. So the first thing I'm going to do is I'm going to draw back my regular Bohr-Rutherford diagram for lithium, okay? So inside you have 3 protons, you have 4 neutrons, then you have 1, 2. I'll make these bigger. Okay, that's the regular lithium Bohr-Rutherford diagram. But what about the ion for lithium? So now what does it look like? Well, let's choose a different color. We'll do it in green. So now your nucleus still has 3 protons, because remember, the number of protons and neutrons will never change. It still has 4 neutrons, but now it's going to have lost the 1 electron. So now it only has 2 electrons. So now you have 3 protons and how many electrons? 2 electrons. What do you have more of? Do you have more protons or do you have more electrons? Well, you have one more proton, and proton has what type of charge? Positive or negative? It has a positive charge. So look at the charge that lithium now has. Lithium has a 1+ charge. Now, that is the way you figure out the ionic charge. The ionic charge is the difference between the protons and the electrons. So you subtract the numbers, and that's going to be the charge number. And then whether or not it's positive or negative is going to depend on whether or not there's more protons or electrons. In this case, I have more protons than I do electrons, so the charge is positive. Okay? Now, let me just erase this all and draw that again for you. So the lithium Bohr-Rutherford diagram is going to include the symbol for lithium. You're going to include the charge. Okay. Then you're going to draw your Bohr-Rutherford diagram. So you're going to have your nucleus with your 3 protons. You're going to have your 4 neutrons. And then you're going to draw your Bohr-Rutherford diagram with the gained or lost electron. So in this case, it lost an electron, so now it only has 2 electrons. Okay, so this is what your Bohr-Rutherford diagram would look like. You're going to include your symbol, including the charge, and you are going to show your Bohr-Rutherford diagram with the missing or gained electrons. In this case, it's 1 electron down, so it's lost an electron, so now we only have 2 electrons. So this is the Bohr-Rutherford diagram for the lithium ion. Okay, all your Bohr-Rutherford diagrams for ions should have a full valence shell. If it doesn't have a full valence shell, you haven't done it correctly. Okay, so now let's do the next one. So fluorine was your other example. So fluorine, as it's found on the periodic table, has an atomic number of 9, and it has a mass of 19. So that means there's 9 protons, 9 electrons, and 10 neutrons. Okay, so the atomic number tells us the number of protons and electrons, and then if you subtract the mass from the atomic number, you're going to be left with the number of neutrons. So if I were to draw the Bohr-Rutherford diagram for fluorine, it would look something like this. So inside your nucleus, you have, actually, let's do it down here. Inside your nucleus, you have 9 protons and you have 10 neutrons. Then in your first shell, you're going to have 2 electrons. And in your second shell, you're going to have 7. 1, 2, 3, 4, 5, 6, 7. So if you count it all up, you'll have 9 electrons in total. Okay, so now we have to decide, how is fluorine going to become stable? How is it going to form a full valence shell? So how many empty spaces are on its last shell? Well, there's 1 empty space right here. So fluorine can either gain 1 electron or it can lose 7 electrons. So which one's easier? Well, I hope everybody chose the gain 1 electron. So actually fluorine is going to gain an electron right there to obtain a full valence shell. So what will the ion of fluorine then look like? So it's still going to have 9 protons and 10 neutrons, but now it's going to have 2 electrons in its first shell, and it's going to have 8 electrons in its last shell. So the Bohr-Rutherford diagram would show a full valence shell, which this does. Now we're going to figure out what the ionic charge is on fluorine. So I have 9 protons, but now how many electrons do you have? So if you count them all up, you're going to see that you have 10 electrons. So what's 10 subtract 9? You have 1. Now, do you have more electrons or more protons? Well, you have more electrons. There's 10 electrons and only 9 protons. So what charge do electrons have? They have a negative charge. So fluorine's going to have a 1- charge. So your Bohr-Rutherford diagram is not only going to include the diagram with the complete full valence shell, but it's also going to include your atomic symbol and the charge. And remember, your charge comes from the difference in the number of protons and electrons, and whether or not it has more of the positive charge or the negative charge, okay? So I hope this helps. If you have any questions, feel free to email me.